Hey everyone. Let's see if we can get this going here. Make sure everybody can hear me okay because I can't hear. And kept telling me I was in a different meeting. So you can hear me? Okay, perfect. That is excellent. Cool. Well, hopefully this helps the scragglers here a little bit. And we'll give it just a second as I get a couple other things set up. Awesome. Thanks, guys. Cool. So let me pull this up. Hopefully that'll work. Can see everything. Great. Cool. All right. Well, I'm going to go ahead and get started. The webinar for today, from initial access to persistence, we're going to be taking a look at passkeys, how they can be registered as an attacker and then used in very interesting ways. Before we get started too much, though, want to thank Altered Security for hosting the webinar, putting out the communications, helping everybody get in here. Really appreciate everything that Mikhail does, and just super grateful that he asked me to come in and share some things. So Hacker Summer, a month-long red teaming event, lots of different webinars, people who have interest in different areas and just sharing the things that they've learned. And so I just love the opportunity to come in and share all the different things that I've learned along the way. And hopefully others can take that and run with it in their own different ways. So some call for papers and discounts, giveaways, and things that he's doing there as well. So hopefully everybody's in the Discord. I'm trying to pop that open here real quick on this side. Kind of keep track of what everybody's talking about, see if there's any questions. So cool. Awesome. Looks like, I was a little bit late there and a couple of people were like, hey, is this going? So it's pretty cool. All right. So with that, I am Nathan McNulty. I'm a Microsoft MVP in security. I'm a principal security solutions architect at Patriot Consulting. I've been here for about 5 years. We primarily help customers secure Azure, Entra, Defender, and I do Intune as well, Purview, of course. So just Microsoft Suite type stuff. So pretty fun. I worked a large school district, about 50,000 students, 90,000 devices. And so I helped build our security program there for the last half of the time that I was there. Just a great environment. So I came up through help desk. Sysadmin, client architect, security architect, or all that kind of fun stuff. So learned a few things along the way. I am a little old. Been around since it was Business Productivity Online Suite, or actually before that it was Live at EDU. We migrated to that, and then Office 365, and now Entra. And so I've been working with a lot of this Entra related stuff for, my goodness, 16 years now, 15 years. So be cool. I'm not actually going to have like little video placeholders in some of these. We're actually just going to do a lot of demos mostly. So I'm going to hop in and show Evil Jinx. So there is a feature of Evil Jinx where we can do event notifications. So somebody lands on our fishlet, we can send them a communication, and it's pretty cool. I don't have Evil Jinx Pro, so it wasn't able to quite demo that piece. I did talk to Cuba, and he was okay if I shared some of the things that I did with it. So, and also there was some things with Evil Jinx that it couldn't do that I really wanted to be able to do for this specific demo. So I may have modified a little bit of the source, and I published that on my GitHub repository. So we'll get into that a little bit later. But as you can see, you can actually send some custom tokens and things. And so I kind of stole that concept and just baked it into my own HTTP proxy go file. So we'll set it up here and come on over here. So I've got Evil Jinx, right? I've already installed or cloned, I guess, the repository, set up DNS, set up all the other things here. So let's go ahead and do that. So I've got Evil Jinx up and running. I've already got the TLS certificates. Everything is all set for this. We can actually take a look and see what our fishlet looks like. Oops. We'll do fishlet get. We'll take a look at that. So I'm redirecting a couple of URLs that I really want to intercept, or I guess domains. If I take a look at my lures, can take a look at what our URL is here that we've got set up. So I actually took a template from Yehuda Smirnov, hopefully I said their name correctly, and modified that a little bit. It's kind of a unique one. I like it. There's a downgrade attack against Windows Hello for Business with this. And so it recognizes, hey, the user's already in, has a FIDO2 kind of type credential. When we go to log into Microsoft it takes the username when you first type that in, and then it does a quick check to see like what kind of methods this user have registered and what's their strongest one. We have this system preferred MFA option, or whatever the most recent one was that was strong that it'll try to prefer for that device as well. And so, we can't phish FIDO or phishing resistant authentication. So let's say, hey, I want to click that button that says use another option, really. But we're doing that transparently for the user. They never see that page. It looks like a little bit of a delay for them, right? And then they get passed on to the phishing page. So I've made some modifications to this. I won't spoil the surprise quite yet. But now that this is up and running, we're going to hop on over to our victim computer and just whatever your pretense is, that you got that user to click a link, or maybe this stuff that I'm showing will also still work if you have malware. You're maybe stealing tokens off of the device. So that's always an option too. But in this case, we're going to go to the phish. I got to get my phone open too. And I chose to do OTP because doing a demo and that kind of thing, it's a little bit easier. So we're going to go victim at my lab. We'll go. There we go. And that code, let's go ahead and type that in. And perfect. So, the user, oh, well, something weird happened. I don't know. Okay, I guess I'll go try to log in again, right? On our side, of course, we have now captured the details. Nice try, FBI. We've got a bunch of fun stuff in here. And so I did a little bit of modifications. We'll dive into that later. But I did just steal, the tokens from that user. And so on my machine here, let me go ahead and hop on over. I do have a Gab repository. This is public. You can go check it out. There's a browser extension here. We just add that. There's a public, what am I looking for? Yeah, the public folder has a distribution. We add that passkey provider thing here as an extension. So let's go ahead and pop that extension open. It does require a key vault be configured on the device. In Azure, that you actually, there's like a wizard it walks you through. So I built this, deploy some resources. Again, the scripts are actually in here to deploy the key vault. And we're going to go ahead and log in. So I'm going to unlock this. And so now I'm logged in. It does use easy auth, so it's integrated with my Azure instance and with my Entra. It has an application that handles the authentication, allows you to basically broker app, right, to talk to the key vault. And down here, I can see that, oh, there's my victim. So we're going to go ahead and open that. And now we're going to use the fingerprint. Sometimes I was able to get around that by setting prompt equals none, but it wasn't working for this one. So that's okay. We'll live. And now we should be, oops, let's try that one more time. Sometimes that prompt equals none. Sometimes that ends up booting it out. So we'll try that one more time. Again, bugs you can fix. It's great. But it should land us in the user's mailbox. And now you can see that I am logged in as the victim on my attacker machine, right? The one I'm running. Well, I'm not running Evil Jinx off of it. I don't know if you noticed, but down at the bottom, SSH'd into the box because WinSCP and all that fun stuff, getting files over to it. But yeah, so there's the warning. Hey, I have a bad feeling about tomorrow. So don't click on that link. So pretty cool. I now was able to log in using a stored passkey as that user. So we'll dive into kind of what all happened in the back end there. But we phished the user, sent a webhook to a function app that then registered a passkey. Both the phishing infrastructure and the key vault and the function app and all that kind of stuff live behind the same NAT gateway. So according to everything else, it looks like the same device, same IP, all that kind of stuff. So everything's right there in the GitHub repository if you want to take a closer look at that. So pretty neat. So, you know what? I missed doing something. So let's go ahead and hop back in here. Let's go to here. So typical response that we would have on incident response, or we see that something happened, right? User notices something, maybe an alert got fired, whatever that might be. We're going to come to, our victim here. We're going to say, you know what? I got to revoke that user sessions. I'm going to have to reset their password. Super common. And actually, Microsoft just added a new Entra SOC like identity responder, I think it's called, role. And within that role, it's designed for this type of an issue. And so we would come in and revoke and reset the passwords. They gave those two roles to it, or permissions, but they did not give the permissions to remove authenticators. And so, as we can see, there's a passkey here, but they wouldn't be able to remove that passkey that we just registered. So for the end user, if they were logged in, they would notice that they got logged out. For me, as I'm, the attacker and I'm in here and I'm clicking around, hopefully it does it. Yep. Boom. We lost our session. Not a huge deal though. We have a passkey, so we can hop right back in. Maybe you lay low for a while and you don't even use this thing. Wait for all that kind of stuff to happen. Whatever it is. But now we're back in, even though the password was just reset, and I didn't even have to use the password, right? Because I registered a passkey. So that's kind of the big concern that we're worried about, is they don't have their playbook properly handling passkeys today. So good takeaway for them. And definitely a persistence mechanism, right? This thing is, there's no expiration. It's not like a certificate. It doesn't expire after a year or whatever the PKI might say. These are more like SSH keys, and they just sit there forever. So pretty cool. So let's go ahead and hop back over here. Yeah. So traditional playbook, we go in, we change password, we revoke sessions. A lot of times that is already orchestrated. So we have some logic apps or something with Sentinel or whatever your SIM and SOAR may be. And so we go and we hit that button and it just goes and cleans stuff up. We need to make sure that we're actually handling the authenticators as well and making sure that we're clearing those out, removing them. So pretty cool. So yeah, the attack, the mental model, because I did have a lot of questions previously about this. The mental model is not that we like abused a passkey. We didn't actually not in the way that you're thinking. We didn't steal the passkey from the user. We didn't break anything to do with the way the passkeys work. They're very sound in that way. What we did was we captured the ESTS auth for that user, and then we passed that through and used it for registration of a passkey. And then now once we have that passkey in hand, we can use that to authenticate anytime that we want. So I don't know if you're familiar with ESTS auth versus ESTS auth persistent, but there's a specific, like the persistent one is great because it's long lived, it's a longer token. The downside is it's not eligible for the My Sign-ins page with Microsoft. And so we can't use that to replay to then register an MFA method. And you also have to do that within 5 minutes. So this whole flow of using the webhook rather than hoping that you catch it in time. Oh, interesting. I think questions are going to go in the Discord. Sorry. Well, I'm going to hit deny on that and you can toss it over there. Yeah. So ESTS auth versus ESTS auth persistent. When we take that ESTS auth persistent and try to pass it to my sign-ins, it's like, hey, you can't use that. I don't know what that is. With ESTS auth, that was the version that we had to use just through reversing, the page and everything. And what all happens when we register a passkey. It needs to be within the last 5 minutes or it'll be invalid. And so that makes it really hard when we capture that from EvilJinx. Then we go copy that code or pop it into, take the cookie jar, like put it into the browser, go and try to browse to that page to then register something maybe with our own passkey. You really have to do that quick, right? Within 5 minutes. And you have to come from that same egress IP, same operating system being passed through that was originally done. And so even if the user agent string is a mismatch at all in any part of that process, it will not let you register that passkey. So that's part of the nice thing. We actually capture the details that we need. We pass that through to the function. The function then uses the user agent and all the other stuff that we would want, logs in from the same IP as everything was captured from. So it matches exactly what our phishing kit said that it was, and then registers that passkey for us. So nice and clean. And cool thing about the key vault, it's just secure, right? I do have the option in some of my scripts there where we can actually save that passkey out as a file, just a flat file. But it does have the actual key material, same as your SSH private key would be. And I never really liked that, where we've got these key files sitting on disk and, it's just the OPSEC side of things, added risk. So it's kind of nice. We can put it out to a key vault. You'll see some references to like, hey, it's, once it's in the key vault, you can never take it out. We can make exportable keys. I chose not to in my samples, but if you had like a real need where I need to be able to copy these out and be able to use them again, you could certainly flip that bit and make it so you can do exportable keys instead. So a lot of stuff on the Entra side and Okta side, which I actually have some Okta examples as well. You just lie to them. Just be honest. There's a whole thing around attestation, so we'll hop in and take a look at that as well, and we'll get deeper into it. So I think it might be helpful to talk about passkeys, the way that passkeys work, the public key credential, private key credential. If you're familiar with SSH keys, it's very similar, right? We've got our private key we generated. We have that on our local. We go to all our server hosts. We drop this public key around and say, hey, this is authorized to be used for accessing the servers and things. And then when we go to connect, it just does this nice, strong authentication. It's not quite a certificate. There's no like a PKI we have to go talk to and check for revocations or any of that kind of stuff. But, if that host, they delete the public key, no big deal. We just can't connect to it anymore. And so the same thing, somebody said, hey, let's take that and improve it and use it with browsers and all that kind of stuff. So that's really passkeys in a nutshell. The relying party or identity provider, they're going to have that public key piece, and then they're going to send a challenge down to our machine. We sign that challenge and prove that we, still hold that private key, that we are who we say we are, and then send that signature back up, and then they authenticate us and say you're good to go. So I'm not going to read this section. I've actually got a nicer little like a graphic. So we'll actually take a look at this. So I kind of like this little drawing a little bit. So yeah, so the user begins, we go to a site, maybe it's Home Depot or maybe it's Entra, right? Whatever that might be. We're going to go to register, or they may prompt us actually at the login, or we go to our My Security Info page, or, you're in the Microsoft Authenticator app or Okta Verify or whatever it is. You're going to hit a button basically that says, hey, I want to start the registration for a passkey. So they're going to go over to the relying party or the identity provider and say, hey, I need challenge, nonce, all the different things get created. And so what's kind of neat about passkeys is it's controlled by the operating system. It's not dependent on every application having their own like weird implementation and somebody did it wrong to a certain extent. Instead, we're actually passing a lot of stuff off to the operating system to do. So we're invoking a create against the OS or against the browser WebAuthn, right? And then the operating system handles a whole bunch of stuff for us, which is really nice. And so, yeah, we're saying, I want to create this. Now the user has to do an approval, right? So they're going to do like touch it, show that they're there. We need some sort of proof of presence. And ideally, if they've never set their authenticator up before, they're going to have to set up some sort of gesture. And so that typically will be a PIN. PIN is default and required as part of the spec. And that's primarily because the other options are biometric, which fail us, right? So I do some woodworking sometimes or in a pool, and now my fingerprint doesn't work. Same with face, things happen, maybe mask, hat, whatever. And now biometric isn't working. We need some safe fallback. So PIN is going to be that. So we have a couple of options. We have synced passkeys, and then we have device-bound passkeys. Obviously, device-bound stronger, right? It's not leaving that secure enclave on that device. And so anyway, the private key is generated in one of those, and then potentially that private key is synced back to iCloud or Google Password Manager or something like that. And so anyway, we're creating this key pair, in that way, and possibly syncing it. So we've got that down here. And then there's actually a piece that's not shown on this little, let me go back here. There's a little piece that's not shown there. So we have a thing called attestation. And with attestation, it says, hey, FIDO Alliance has actually verified that this implementation is good. So we're going to we have a private key that kind of corresponds to that. It's published as what they call an AA GUID. And we're signing this authentication package or whatever you want to call it, the challenge with the public key attached to it. We're also adding that attestation piece to say, here's a provenance. I'm coming from a YubiKey 5, right? And so we send that on up to the identity provider or the relying party, whatever that might be. And then they save a copy of that public key. And then every time that we go to connect afterwards, we do a get, they call it a ceremony, right? So there's this first ceremony is the create, and then the second ceremony is the get. And so when we go and talk to that relying party, let's do the video again, because I prefer the visual versus the words there. That user, again, is going to go visit that website. And the website's actually going to be looking up that user and say, hey, I already have that user in here. They already have a public key. I don't need to prompt them to do a passkey registration. Maybe if they're like working on upgrades and that kind of thing. So the user will do the get, right, to say, hey, operating system or credential manager, whatever, I want to start the authentication flow here against this website. And one thing I kind of forgot to mention, they're doing it based on the domain name. So if they see that it's microsoftonline.com or login.microsoftonline.com, that's what it's actually getting saved into the credential, the authenticator as. And that's why when we like Twitter changed over to X, everybody had to re-enroll all their keys because everybody registered them against twitter.com, and then now they had to go through x.com. So they did this weird interstitial thing where they'd redirect you to Twitter for the you know the FIDO authentication flow, and then, or the web auth, and whatever you want to call it, and then passed you back over to X. And so they kind of cheated for a little while, but then they said, hey, we want to stop doing that. So we had to re-register. So it does match the domain. Anyway, so down we do the user approval, right? I got to touch proof of presence, and that is a requirement of FIDO. It is not a requirement of the synced, though, actually. So there's a lot of things we can lie about here. So we'll discuss that a little bit. Regardless, it's going to take that challenge that came from the identity provider or the relying party. We're going to sign that with our private key that we have, and whether that came down to our device from our synced provider or we have it local. Anyway, we'll sign that attestation again. If it's there, it'll do that as well. Anyway, whether the attestation is trusted by the identity provider or lying party is a totally different thing. But we send that package up to, the identity provider or lying party, and then they validate it. And yeah, that matches the public key, and you're good to go, because I was able to read that assertion that you are who you say you are. So, so the browser binds that ceremony to the origin. So we log on.microsoft.com. So I'm sure many know this. Outside of a true attacker in the middle, like TLS interception, where we're really intercepting the true domain. So you would need Microsoft's private keys, right, to intercept that. We're not going to be doing an attacker in the middle and phishing FIDO2 type stuff. There are some weird tricks you can do, getting people to register. If you give them a QR code or something, and then your device is nearby with Bluetooth, and you can kind of fish them into like registering a device, and then they connect to you. Anyway, there's a kind of a neat attack around that, but you have to be in proximity. So not what we're typically concerned with on this. So, anyway, the fun thing about this specific attack, it's not during the we're not using the credentials that we stole. We're actually registering new ones right afterwards. And so it doesn't matter about the initial session. The session was just a throwaway, and we're handling everything after the fact. So we didn't need to actually intercept the true real domain in this case. So they have two flags that are set during the ceremony when we're doing registration and actual authentication against things. We have the user presence. We got to just verify that they're actually there. And so that's why you always have to tap on the authenticator. Unless you got the bio model of the YubiKey, most of them are not actually biometric, even though it feels like you should put your finger on it. Some of them even look like they have a fingerprint icon. I think it's more just to tell you have to touch this. But most of them are just like a sensitivity, like, hey, you just touched it, kind of a thing, right? A sensor. And then there's user verification. So there's that local verification, which is a gesture, is what we typically call it, a PIN, biometric, something that unlocks and tells it. So I'll tell you, like Bitwarden, 1Password, a bunch of the others, they don't do any of this stuff. We literally just lie about it and send it on through. And so that's what I've done with my browser extension. I actually added the PIN. It's kind of fun. As I was building it, it was for an AI PAM type solution, I guess, that I'm trying to just play with. Put all the global reader, whatever else into Key Vault, and then I can, whenever I want, allow agents and things to have access to credentials out of the Key Vault. I was like, I could probably use this. So I just flipped it, and we're having some fun today. But the user verification part, I want to make sure that whoever's at the device, they're actually typing in the PIN or something to unlock access to the browser extension, because they're going to have access to all these keys. And so I really wanted to implement that. I found out that Bitwarden and others didn't have that, because I was taking a look at their code to see how they did it. And so anyway, that's why I had to type that PIN in there. But yeah, we can really just lie about most of this stuff when we send it through. I actually pushed through that these are device-bound passkeys. We can send multi-device if we want to. That'll show up in the in Entra or wherever you're registering your passkey with, that, hey, now it's a synced passkey in there. So if they don't allow that, just change it to single device, right? Say that it is device-bound, and you're good to go. You can lie about user verification, presence, all that kind of stuff as well. So there's nothing stopping you from doing that unless they are enforcing attestation. And Okta doesn't enforce attestation by default. And Entra is somewhere in the middle. They do for some people who had stuff already configured, and then they don't for others. So There's a newer default. They're trying to really push synced passkeys, and synced doesn't support attestation. So we're kind of stuck there. So yeah, that's that attestation piece. I think I had a little browser section open here. Yeah, perfect. So FIDO Alliance publishes a thing called a MDS. It's a metadata service. So when a company like YubiKey wants to get their passkeys certified, they will contact them. They review the configuration, the settings, the software stack, or I guess, or firmware stack, or whatever you want to call it, that's used for the implementation. And they sign off on that implementation. They'll say, hey, this is approved and certified. And so you'll sometimes see that attestation certificate or the AA GUID maps across multiple devices for them. So they'll have lots of different styles. So it is not unique per each key. It's not unique per each provider or per user. So that's actually intentional. It's a privacy preserving feature that the FIDO Alliance developed. So it just really says it's somewhere in this model or firmware version. So you may notice that YubiKey 5 has 20 something different like AA GUIDs associated with it, because some of them have had vulnerabilities. And so they've re-released it as a new stack, and that had to go through certification again. And so anyway, what happens? FIDO Alliance, they publish this MDS, and then identity providers and relying parties. So relying party being just like a standalone application rather than a true full-blown IDP like Entra or Okta might be. They're going to consume this MDS, and then that's how they verify that you actually truly have a strong provenance and device bound authenticator. And so that's kind of how that works. That's that whole chain. And then we can actually do some neat things with those AA GUIDs on Entra or Okta to say these are some restrictions on which keys you're allowed to use. So if we're not enforcing attestation, there's some neat workarounds for that. If you happen to know some of them for YubiKey, you just try a few and see which one works. You can just lie. They're not really checking. They're just checking an allow list. And if you happen to hit the AA GUID that's on that list, you're good to go. So it doesn't have an answer to every security question. It does at least say, hey, this is the declared model in metadata, but it doesn't actually mean that truly is what it is unless that public key or that signature on there matches the public key that's published in the MDS by FIDO Alliance. So otherwise, we can put whatever we want in there, sign it with a fake attestation certificate, and the IDP, if it's not checking, it doesn't care. We're not enforcing attestation, then it doesn't work. So that's kind of a key takeaway, right? We want to enforce attestation when we can. So some things that it doesn't tell us, like who has that key. I don't know. Is my kid? Did they plug it in? The type of thing. Is it on the iPad? Microsoft Authenticator. They just opened the app and it just prompted. Well, it's the same as the lock screen, so I just type that in. Good to go. There's some real concerns, I guess, but really it's much better than username password typically. So synced passkeys, they trade that provenance for recoverability. It's a really nice experience, honestly, for users. We sync this into our cloud provider, iCloud, whatever, and the focus was on consumers, not on enterprise. And I think it's a huge win for them. They don't have to come up with passwords. It's much stronger than any password they'll ever come up with, and it has a good recoverable, option there. And we just focus on, when somebody registers a new device, if you've ever had to go through changing phones, it's kind of a pain. And so, yeah, like you have to go back to the old one, approve, and all this other stuff. There's like tons of extra steps. So it is a little bit harder to phish and take over somebody's consumer account. And so that's kind of the nice upside, I guess, to that. So. Yeah, so that's kind of the basics of the of passkeys, kind of how they work and all that kind of stuff. Thought it might be fun to take a little closer look at the infrastructure that I built and kind of how some of this stuff works. It is the shared egress for that. I use a NAT gateway, printing it, not too terribly expensive, but it does add quite a bit of cost. Not quite free, but we'll sit the VM behind that for our fishlet and then, of course, we share that with the function app. Now they have the same IP outbound, same user agent strings optionally, like all kinds of stuff you can do with that if you really want. And then because it's in Azure, we get some really creative things. Like we can deploy this into any region where Azure is. You could probably do the exact same thing with AWS and Lambda functions and all the other stuff too, or Cloudflare. Just pick a data center, tweak this for whatever your preferred hosting is. But yeah, we can do all that kind of stuff, deploying it to regions, also overlays, network overlays. Go ahead and reroute that traffic from wherever you want it to be rerouted from. So we are capturing, of course, the IP, the region. It's not unthinkable that we could say, hey, this user's incoming from these areas, or we happen to know we'll just spin something up over in that area so that we're coming from a similar region to them. So then we're not hitting like atypical travel or impossible travel, I guess, and some of those kinds of detections and things. So cool. In my testing, I actually brand new Evil Jinx box I spun up here, right? And I didn't get any alerts or anything from identity protection. It could be just it's still learning because they were relatively new users that I was testing with. But anyway, so your mileage may vary. Let's see here. Yeah, so I'll hop in and actually show a little bit more about that infrastructure here. So yeah, here on this proxy, the key thing or the YAML, which is also published in that in this GitHub repository that I'll share, I guess, in a minute. So we're doing the login to microsoftonline.com and the mysignins.microsoft.com. That's where users would typically go to register their passkeys. A lot of them don't even recognize that that's the name of the place because their IT told them to go to aka.ms/mysecurityinfo or /setupmfa or MFA setup or whatever. There's a whole bunch of them. So that's kind of like the key important parts about that. And then we also need to make sure that we're always capturing the ESTS auth. We actually don't need some of the other pieces there. The redirect itself, I actually added that to this. That wasn't there either. So I didn't really want them to land back into Microsoft land unauthenticated in case they weren't signed in. Send them somewhere where it feels like, wait, what just happened? That was an accident. Something wasn't found, and then they'd try again kind of a thing. And of course, we've got this like downgrade kind of thing that they, had created, Yehuda had created there. So kind of cool. HTTP proxy. So this is a kind of important one. You can have my function key. I don't care. Send random stuff to my webhook. So I extended this custom webhook here. So we're going to drop in our function app. And so we'll take a look at it in a second where we grab that from. But then it just sends a webhook through with certain information. I actually modified this HTTP Go proxy Go to prefer the ESTS auth over ESTS auth persistent because it does prefer that by default because it's kind of better, right? It lives longer than our ESTS auth. So anyway, so we've got that little piece there. And if we actually do a quick little, let's grab our send a webhook, copy that and come on down. There's one more a little bit further down here. And so there's a little section that you'll want to modify. So these are the two main modifications that I did. I also modified sessions.go so that it would save a bunch of this detail for debugging purposes. So that is published in my repository, but it's not really necessary for any of this stuff. These are the only two pieces that are really needed. And it's the only modification I made in there. So as you can see, we could put any display name on that passkey we want. There are some characters that aren't allowed, and there is a key length. And you also have some limitations with key vault. You can't create the secret with the key with the same name. So you do need to make sure that you're doing some sort of randomization. If you were to statically set the key name, your first one would work and then your second one wouldn't. So a few kind of notes there, but otherwise we're capturing a bunch of stuff. The JSON ended up getting too large for the function app or what. Something along the way. Anyway, got too angry, collecting basically all of the cookies and shipping them through. You could certainly play with that if you really wanted to save it long term. We're actually pushing out to table storage and the key vault, and you can use secrets too. But anyway, so you can retain a bunch of this information if you want to store it all in Azure instead of taking a look at it on your VM on your Evil Jinx box. So anyway, those are the two modifications that I made there. So what's really happening under the hood? Let's come back over here and hop into Azure. So I've got this resource group. I have a function app in there. That's the one that's doing all the heavy lifting. We've got the key vault. That's where they're getting stored. Most of the rest of this, or storage account, I guess, is storing some things for us too. The rest of it's just kind of logging and debugging and all that kind of stuff. So it'll get deployed with the templates that I have. So you can actually just straight deploy these. There's some bicep templates in the repository as well. That just deploys right out to a resource group. If you're not sure how it works, any of the open source models really just, you can ask it and it'll deploy it. So you don't even really need a subscription. But anyway, so it's all there. Pretty cool. So the function app, We'll pop that open. I think Lambda function. I mean, it's just very lightweight, serverless kind of thing. It doesn't really need much flex consumption. Making sure you're selecting that one. That's in the template. It's not going to charge you anything to just sit there. It doesn't charge until it actually gets used and spun up. And for a few seconds that these things are running, there's like practically no cost at all to that. So I've got a whole bunch of different functions in here. You'll notice that there's some of them that have to do with like getting the octopass key registration. I actually have that fished as well. So anyway, there you can play around with a bunch of these. The HTTP triggers are very slow. So if you try to use an HTTP trigger on your Evil Jinx box, it's actually going to make the user wait. It's going to sit there until the function returns a result back. And so that whole process of registering a passkey can take, I don't know, 15, 20 seconds. And then there's also, if you're doing a cold or a cold worker, I guess, you can pay extra on the function app to have it always hot, but then you're basically paying for a VM. So we usually leave them cold, and then they queue up a job, and then you have to wait forever for like a container basically to spin up and start running the stuff. So if you do an HTTP worker, it could be a minute that the user's sitting there waiting for their password or whatever else to like finish and let them out to the next thing. So they get suspicious. So there's an alternative option for queue. So what we're actually going to do is we're going to use the HTTP to pass the information directly into the queue rather than processing it inside the HTTP triggered function. And so that's what's happening. This queue, actually, if we go here and take a look at our invocations, you can see that most recent one, if it'll load. We have that 202 we kicked off at that time, right? And all it says is, hey, I took some information and I passed it over somewhere else. So there was really nothing that happened inside of this one. All the magic, took us back up to the top there. All the magic really happens inside this process one, which is a queue based. So the cool thing about the queue is that HTTP is really fast. As people are doing them, say you had 3 or 4 that flowed through, they're each going to drop into a queue and they'll just process sequentially. So your users aren't waiting for that HTTP one because they release really quick. They're just passing a little JSON snippet to the next one. But then the next one is actually holding a queue in place. And then that's what's processing. So you can have a nice backlog if you really wanted to. If you wanted to dump everything out of a PAM and just pass it straight in and provision passkeys for everything in a PAM, you technically could do that. So anyway. So yeah, pretty cool. It's all in there. We'll take a look at the invocations because that's where we actually see the run history or details without having to go to the application insights and doing queries and stuff. But before this was reusing something I'd already built. So we had this nice logging. Hey, I made it how far? I took my ESCS auth token, I injected it, exchanged, talked to the relying party or IDP, made the request, put it into the key vault, all that kind of stuff. So you'll see lots of the details all get stayed in here. So yeah, that's super helpful. The other side of it, if we come back out to our, I want to come back in here. So that's going to be the function app. It is doing some writing of details out as part of that function. It's writing some information that we might want into storage because, like I said, a lot of this I was registering my own stuff for use with like an AI PAM type solution or something else, and I need to be able to like look this stuff up. So I'm storing the metadata inside of secrets or inside of the storage accounts, and that way my browser extension that I built over here can actually go and find my stuff and open it or remove or whatever that might look like. So if we come down under queues, actually is where those the registration queues live. So if you ever get something that's like hung up in there, you can come in here and clear that or dequeue the message, that kind of thing. But we end up storing these passkey credentials and details in here. So you'll see how I saved it, and there's the passkey for the victim, the key vault name, passkey name. Some of the different details are in there, and this was a previous one actually. So there's a couple of other pieces in here. Yep. So tokens are captured. We got a 302 is where we captured that from. In the blob containers, we also store a bunch of information. So you'll find like the actual user's password and some other stuff. So you can download that JSON and look through all the details and the run history from those that we were looking at. So anyway, kind of neat, just logging type stuff there. So yeah, that's going to be all of that piece. Outside of that, yeah, I think that's about it for that. I think we're good. I'm going to double check and see if there's any questions here because, yeah, so for persistence, do you generally recommend registering passkeys over Hello for Business keys? So Hello for Business keys requires that you actually have a device that is quote unquote registered or go through at least that flow that says, hey, I have device registration. Now I can do that. So yeah, actually, It's another thing I built. Under script or under the samples, I might have an interop with, oh, did I not push it? Let's see here. Is it under Python? Samples. There we go. Intra. I might have an interop with Road Tools. So there's a little setup here. So yeah, if you really wanted to like ship that over to Road Tools and do device registration and do a Hello for Business passkey, you certainly could do the same thing. Yeah, so it's interesting. Yeah, Hello for Business is nice. I mean, this is something that you have control of, and I don't know if I could. I'll have to look and see if we could actually take the Hello for Business real one and actually stuff it into the Key Vault and make it register the exact same way. Like take Road Tools, modify it slightly so it's backing it into Key Vault, and then we could use the same kind of tooling and stuff. It's interesting. So yeah, as far as tradecraft, I'm really not the like absolute best person to ask on that because I'm usually chasing things down rather than creating it. I mostly do the creating to test things and then that kind of thing. So anyway, yeah, pretty cool. Let's hop back over to, I think that's it. Yeah, I'll hop back to this. There we go. Cool. So now that we kind of understand what the attack infrastructure looks like, this is kind of the part that I live day in, day out, as I help customers, is really like the recommendation side of things. Like, what do you need to do to fix this? Which I know is probably sometimes a harder thing. When you're on the offensive side, you're like, look at all these cool ways I found to break it. But then like, shoot, what all do I do to fix this thing? So this will be a fun part for us to go through. The Entra configuration to determine whether a passkey can be like registered or not, it flows through quite a few steps actually. So we'll hop into the portal and actually take a look at this. But first of all, is it even turned on? And now Microsoft has been enabling it by default. They rolled out a feature called passkey profiles because previously FIDO was just on or off for the tenant, and then you specified the users who were allowed to use it. Now, and even historically, we always wanted to say, hey, for our admins, we want to make sure they're using these specific YubiKeys, but for these other things, we didn't want them to, or we only want them to register these things, and we don't want them to register others. And we didn't have the flexibility to do that. And so now with synced, it was kind of like, oh, shoot, we really have to offer some different capabilities there. So passkey profiles, think of them as group assignments that allow determine what combination of options for passkeys they're allowed to use. Are they allowed to have synced or device bound only? Are they allowed to have any key restrictions, attestation, all that stuff is tied into that. So we're going to check and see if it's enabled, if the user is assigned to the group, or if it's to all users, which is typically the default. Who all is allowed to register? Is the self-service button or checkbox checked? So that's important. The passkey type, is it device bound or synced? And that actually matches up against the policy. So my recommendation is always attempt device bound for something that's like an attack scenario, because really it's requiring that we do attestation anyway. And it's more likely they left the device bound but not synced, so that'll probably give you better success in that regard. Attestation, we're checking to see if they're actually enforcing that attestation and have an GUID set in their allow list. If it matches that list, if they do have that set, it'll technically check against the list even though it's not really truly attested. So we'd try some YubiKey 5s or some other common AA GUIDs, I guess, if you wanted to try that. And then device context and conditional access controls and stuff like that will be the final verdict there. So we'll take a look at how we can do all of this stuff. And then that says allow our block. So on the passkey profiles, determine what we can, like what we have to prove. So I'm going to pop on over here and we're going to come down under authentication methods in Intra. And we'll take a look at what that looks like. So under policies, this determines what methods are allowed within a tenant. And so I don't know why that green check, I can't get rid of it. Sorry, guys. But anyway, there's this passkey here, or FIDO2 is what that used to be. And by default, it's going to be all users, and it'll just be set to the default profile. And the default profile will have key restrictions, or not key restrictions, sorry, the attestation enabled by default as the older style. And then the newer, so you're going to have some mixed configs in various tenants, is that, hey, we want to allow for device bound, and all this stuff. And so especially for small business and places that don't have IT shops, it's actually kind of helpful. Microsoft is trying to move them up and boost them. And so that's why we see the dropping of SMS and phone calls here. And they're pushing everybody into into passkeys. So there's going to be a lot of concern around phishing, this kind of stuff, right? Coming up over the next several months because Microsoft is making all these changes, and there's going to be communications going out from IT saying, hey, you got to enroll in passkeys and stuff. So yeah, you got some interesting opportunities there. So anyway, we can target things to specific groups. So we build a profile. I guess I should probably show that first. So we add a profile, give it a name, whatever you want. Whether or not that attestation is enforced, they do actually document pretty well. If you were to hop into the documentation, that hey, if you don't enforce attestation, we're just doing a best guess and check kind of thing. We're not really doing any kind of validation, and so they can lie about basically everything they register. And so that's, I mean, it's more professionally worded, I guess, but that's all in there. So when you enforce attestation, you'll notice you don't have an option for synced because synced doesn't actually support attestation. So we have to uncheck that. Now I have a synced option. And again, we can just tell it whatever method it is, if it's multi-device versus device bound, and it'll just trust us. And then targeting specific AA goods, we can choose an allow list or a block list. So if there's certain ones from like a vendor that we didn't want to allow, or maybe it has certain known vulnerabilities, that'll be probably the most common use case for the block. They can add all those AA goods in here. There's actually some like pre-built in ones for Hello. So you can always steal those. They're publicly available. So you certainly could register something using that AA good. The risk that you run there is that they're going to expect attestation on the Microsoft side that, hey, well, you said you're this one and you didn't provide the attestation. So I'd avoid using it for this type of attack, but you can certainly play around with it. It'd be interesting. So yeah, so that's how we build our passkey profiles. We'll see them all here. This is that self-service checkbox that we mentioned earlier. And then essentially we add targets. So my guidance, if I'm advising customers, is for the majority of your users, try to do attestation enforced. Just use that default, no syncable passkeys at all as the default posture. And that works well. A lot of places already had Microsoft Authenticator deployed, and all they have to do is open their account in that Microsoft Authenticator app and click the Create Passkey button. It's like literally right there. And when they click on that, it may prompt them for a push from their phone if they haven't authenticated to something recently. But otherwise, they'll answer that number match right there, and it just creates the passkey. So that's like the quickest and easiest onboarding they could ever ask for. And so that's what we would recommend. For the users who, can't or just won't, or it's personally owned devices and we're concerned about like enforcing them to install software, and there's that pushback, whatever it might be. Definitely allowing synced passkeys is still way better than username password MFA that we're currently phishing today. Because the truth is once a company's moved most of their users, or at least they know which users are able to always do passkey authentication, they can enforce that and we can no longer phish them. We can still steal tokens off of a device with malware and then ship that and potentially register a passkey and still abuse it in a way that we're doing right now. And I still kind of think that's going to be the future of where we end up landing as everybody moves to passkeys, because it's going to be the only method allowed. So we're still going to need some sort of authentication for victims, I guess we'll call them. So yeah, that's how that gets handled. So kind of cool. So again, that strongest control, we just want to prevent right up front. So if we're enforcing a phishing-resistant authentication, there's two different places we can do that. Then that entire attack chain that we just did, Evil Jinx, is pretty much dead. We're not going to be phishing-resistant authentication. Unless, like I said, you have the private keys for Microsoft's login.microsoftonline.com, and then you have a way to actually impersonate that and do a true phish in there, you're probably not going to be able to do it. And so this helps with that. So we'll hop back into the portal again, like the more demo side of it. There's, like I said, there's two different places that we can enforce that. One of them actually with the policies. So companies don't have conditional access a lot of times, right? Because they're just licensing. It's expensive. So we do have the option to say, hey, you know what? We were just back in this passkeys, and we want that to be eligible for everybody. And then what we're actually going to do is we're going to come back out and say, I'm going to start excluding my users from some of these things or turn them entirely off. Like I don't want to allow for SMS. And so anyway, you're going to come into the various methods that you don't want them to use, either turn it off if there's no users, or we're going to add those users who have passkeys to an exclusion group that says you're no longer allowed to use oath tokens. However, everybody else can still continue to use them until they get into the passkeys enrolled, and then we can add them to the exclusion group. And now from a policy perspective, they're not even allowed to use it. So it'll never even make it to conditional access because we don't really care at that point. So our second spot, we'll hop back over to, shoot, I don't like that. Anyway, let's minimize that thing. There we go. Hop back over to conditional access. There's actually this thing called authentication strengths down here. And so this is where we're going to provide a combination of authentication methods that we might want to use. So in here, we could specify, hey, I only allow for phishing resistant. Common one that I recommend people set up is this phishing resistant plus temporary access pass, because TAP is kind of an onboarding method for that. It's how we bootstrap without giving the user a real password. It's just a time-bound password, I guess, really. And so usually we'll check those and then say, hey, you know what, this is the method that we're going to use. But you can't do a whole lot from here. You'll notice it says it's mentioned over here in certain conditional access policies. So I'd rather hop over here and actually show where we get to that. So as we're creating a policy, we might add our users, our resources, and we might target the users who actually have passkeys enrolled, right? So we don't lock people out. It's probably a better option there. But under the grant controls, there's this require authentication strength, and that's where all these methods that we just created are going to be. There's actually a kind of a fun one with SMS, since that is going away, the SMS and voice. For anybody who needs to like figure out who those users are, you actually create a CA policy that requires it. Seems interesting. Put it in report only, and then there's a scroll up to the top here. Oh, I guess because I'm not in a real policy, I need to actually hop into a real one. There we go. You can view the policy impact. So now you'll actually see all the successes are people who are truly using SMS. So anyway, so we can use those auth strengths as a great way to kind of lock that down and make sure that those users are enforced to use. So with our evil jinx, when we phish that user, even though I'm trying to downgrade, what's going to happen? It's going to go to downgrade, and then it's not going to see any other eligible options because conditional access set, or actually the application when it referred, is saying this is the requirement. You have to use phishing resistant, and then we can't meet that. So the attack dies right there. So pretty cool. So yeah, registration obviously needs its own security boundary. Some places only allow for registration from within their IPs, and that definitely helps prevent this. But that's not a super common policy still in my experience. And actually, historically, I was kind of opposed to it because I'm like, well, you know, if an attacker gets a username and password, I don't really care if they register an MFA and lock your user out. Now you know, right? And now you're going to move forward with getting the MFA registered because, like, I don't know. Anyway, yeah, because whatever, your user got phished and now you got a quick note instead of now them phished and attacker has access for longer. So it might seem harsh. I didn't mean it that way. But yeah, anyway, so we've got this registration boundary, and there is a special action. So within conditional access, we have these things called authentication contexts. It's actually, I guess, an OAuth standard, but there's a special value that we add onto the token. And it's more around an action than it is an application that we're accessing or a resource that we're accessing. So I'll hop back over to conditional access. I'll just show, actually, I think I already built that. So let's take a look at I did actually make a policy for showing that one. So let's see here, harden the security registration information. I'll pop that policy open. Forgot I did that. So the user action here, we've got this drop down, and typically we're dealing with like resources, and I pick Office 365 and all that kind of stuff. So we've got one for user actions, and that's registering security information. That's an authentication context. Actually, it's getting put on the token, says, hey, this action is being performed. So it treats it differently than if we're like accessing a resource. So if you ever look in the sign-in logs, you'll notice it's like not applicable, all the policies, because it only applies to specific actions. We can use those for when somebody activates PIM. It goes and checks the CA policy, make sure certain things are there. So they're really powerful. Your custom ones are down here for the auth context that you have to create them. But so yeah, we're for this policy, we're going to create user action, register security information. We're going to come down to our grant control, and we're going to say require phishing resistant MFA, or maybe device is compliant, or join hybrid device, something that's strong, maybe a network location, right? That's great too. So we've got that as an option. And then you can also do a session control on this for every time. So this way, even if they did have phishing resistant authentication, if the authentication event was more than 5 minutes ago, it'll still reprompt. So this is one of the strongest controls we have on anything that does an authentication context, because even though the attacker stole that token, if they're not using it immediately within 5 minutes, then they're kind of stopped from being able to use it any further. So I would highly recommend that for any risk-based policies, or for hardening security registration information, or device join registration, that kind of stuff. So it's a pretty strong control there. Yeah. Let's see. Yeah, so there's that little demo, I guess I already did. And then device context. Device context can definitely break phishing as well. And so just in general, it'll break it. We can also combine that with, like we saw, the security info registration. So let's hop back over here and we'll take a look at that. So the device state is the one that we're interested in for this. And there's actually a couple of different ways you can do device controls within conditional access. One of them, we have filter for devices. And so in here, we can choose various properties. And what's happening here, the device is actually doing authentication as well on anything that's hybrid joined or like intra joined, registered, that kind of stuff. When the user signs in, they're signing in with their own user account, but also there's a certificate that was created during registration or join process with Entra. So like AD, we used to use passwords. Computer objects would have passwords. In Entra, they're certificates. And so anyway, the device is also authenticating at the same time, and that is put into the refresh token or the primary refresh token that's given back to the device. And so we're not actually evaluating anything at the time that that authentication event happens. What we're actually doing is taking that primary refresh token and we're passing it over to conditional access, and then it's evaluating the attributes of that primary refresh token. So it's looking on there and saying, hey, here's the device object ID, right? That's that authentication happens. So we stamp that into the token and it's signed. So we can't tamper with it. And so conditional access reads that and it says, okay, that's the device object ID. I'm going to go query Entra and grab all the attributes from that specific device ID that match the ones that I'm specifically looking for. And so we can match on some of these things. Some of them are unsafe. So like model, operating system, display name, some of these different things. We can actually modify those from the local host. So if you get admin on those boxes, you can change them and those values will sync, and then you might be able to bypass some filter for device type stuff. So typically we recommend choosing things like device ID or is compliant, some of the immutable device attributes, or things that are admin controlled from the Entra side, or like Intune manages it or something like that. So you have trust type down here. This is going to be our kind of key one. We have three, options there: the intra joined, hybrid joined, or intra registered. And so any of these actually break evil jinx because, well, it's not registered. So we could try to do a fishlet where we like reroute and take the captured token, register, do a fake registration, and do some other stuff there. I don't know how well that actually works, but anyway, this typically breaks the attacker in the middle because we're requiring a device cert that it doesn't have. Same with is compliant. That takes it a step further. Of course, the evil jinx would have to register and then also somehow spoof, and I know road tools, but we can like spoof the compliance and all that kind of stuff too, so that we can then, pass this check also. So there are ways. It's not perfect, but for the most part, this works super strong and well. The enrollment profile name is actually pretty strong mechanism as well. So that's going to take out an Intune and say, hey, these are part of this specific deployment, and that was admin assigned. And so even if we spoof our data into Intune as an attacker, it wasn't admin provisioned, and so that's another thing that could potentially lock some things down. So the is compliant from this perspective is a little different than the is compliant from the grant control. So depending on your user experience that you want them to have from an admin perspective and from an attacker perspective, understanding what's happening, is compliant here will give us a block page, and you just can't access this resource right now. It doesn't really tell us what the reasoning is. So that converged conditional access like error message that it shows, it's pretty generic. We don't want to give the user or the attacker any additional details there. The grant control over here, when we check that require a device to be marked as compliant, it actually does say like the reason why you were blocked was because your device isn't registered. And optionally, if you're eligible, it'll attempt to walk you through the process of registering your device or remediating the risk of it, or the part that's like out of compliance or whatever. So if you're on a Windows machine and it's like, hey, open this and go fix this thing. So that's the user experience differences. But if we use any of these, like require hybrid join, require the device be marked as compliant, app protection policy, some of these things can definitely break the attacker in the middle. And actually, there's one other last neat one. It's down here. You can't tell what they are, but this is like a terms of use. And so there's an option within terms of use that also can kind of break some things. So I'll show that really quick. When we build terms of use, there's a require users to consent on every device. That actually requires device registration, and then that breaks the flow. So I know there's some cool fishlets. They actually can expand the terms of use and like agree to it. So it used to be this was one of our ways of like breaking attacker in the middle. Anytime it's an unmanaged device, we have this terms of use pop up, and so then that way at least the home users and that kind of thing weren't getting phished. So now requiring that consent on every device, that ends up being helpful too. So then we can enforce everything is always registered, and then that also breaks attacker in the middle kits. So cool. So I already did that little demo there. So there are some session controls. They have varying effects. So continuous access evaluation is actually pretty neat. It's not applicable to the evil jinx or kind of like when we're doing attacker in the middle scenario from the network side. But it is helpful for malware theft. So CAE it only works for some of the primary Microsoft apps, though. So like SharePoint, Exchange, Teams, OneDrive, that kind of stuff. And essentially, it's if the IP address changes, or there's a risk event or something like that, the tokens are marked as invalid, and then they're just no longer honored. So the malware may steal the token, but then it's not actually usable anymore. But when we're the ones who are initiating and creating those tokens, then it doesn't apply to us. So it's not going to save us there. Global secure access actually would prevent almost all of this stuff. And interesting note, super important, I think, is it's actually included in your E3 license. So a lot of people, or E5, whatever you might have. Or actually, I think it's P1. So fairly inexpensive license, but it only covers the Microsoft apps with that P1 license. If you want to extend it to all of your like third-party Workday and Salesforce and whatever else other types of apps, that's a separate license piece. And I'm not going to get into licensing, but at the very least, GSA is great for E3 or P1 type level licensing. Cover all your Microsoft apps, and most of your stuff is really secure. So we can require it come through that tunnel, and of course, Evil Jinx doesn't have the tunnel, so that's broken there. Also on the device malware, if a token is stolen, we have universal continuous access evaluation. So global secure access is actually signing all those as they're going through, or it's coming through known good infrastructure or whatever. And so they're marking it as that token. If it's stolen, the IP changes and it's no longer valid. So we can absolutely enforce that on GSA, and all of this stuff stops working, which is great. Token protection, super finicky, only covers the same stuff as CAE, really. It's, Outlook, SharePoint, Teams, OneDrive, that kind of stuff. It's pretty limited. They did just add Mac OS, but I'm curious to see if they start to adopt any of the new Chrome token binding type stuff, or session binding, I should say. It's not token binding, but anyway, we'll see if that happens. And then CA app control, in my experience, is broken Evil Jinx. It's its own reverse proxy, and then the double reverse proxy ends up breaking things. But I think it's actually more that we don't add the imcas.ms into the proxy config. And so anyway, if you've ever fished that's an interesting one to play around with. So some more fun, I guess. We can hop on over and see what now that we've got this passkey as the user, what all else can we do? So I already showed, we can open the user's email, right? We're in as whoever they are. We can browse around and access all the same apps. And because we have a passkey, we can mint a token for any service that we want. It's not limited to, I got a Fochi token. So now I'm stuck with, Outlook and SharePoint, Teams, Exchange, all those fun ones, right? Now, no, I can go and access Azure, and I can access Defender Portal. I can access Purview. I can go hit just about anything, any third-party application they've integrated with the tenant. I just go to my sign-ins, right? My apps.microsoft.com, or applications, I guess. I thought it was my apps. Oh, it is. Yeah. So as that user, and away you go. Cool thing with that passkey provider, hopefully it does prompt. But yeah, usually it'll offer like, which ones do you want to log in as? Oh, I bet I triggered something else there. Oh, because I did the none. Yeah. Anyway, so you can browse around and just do things as the user, flip around between any of your different users that you have. So there's the victim, right? And what all apps do they have assigned to them? And of course, lab, so it doesn't have anything important. But other than that, I've got a bunch of scripts. So going back to, I guess, here. And I don't have, wrong window. There we go. Too many things. So within this research passkeys repository that I've got here, there's a whole bunch of different scripts, whether you prefer Python or PowerShell. I've tried to keep feature parity on both of those. PowerShell is my language, and so that's going to be more feature complete. And I've done a lot more testing on that. I've tried to just, AI generated the Python related stuff. So if that's your language, feel free to like beat up on that, fork issues, whatever you want. Take a look there. So anyway, there's some scripts in here for Entra and Okta. So I've been building those too. So the register for the passkey, but there's actually like a invoke the Entra passkey login. By default, it's going to use the Azure CLI application ID, but you can pass in anything else you want. There was actually an option in here for registering a passkey too. So if you got a temporary access pass or maybe an ESCS auth you captured in some other way, you can definitely register passkeys using those instead. And so that's an option. You can create that can be an output to a local on the device. And so it's just a little flat file that has the details in it. And actually the schema for those are listed right here. So here's our local private key. Credential ID is actually what the identity provider matches that passkey up against. So when we say, hey, this is the one, it's checking to make sure the credential ID matches. Of course, we've got our private key, just like the SSH key that gets stored in there. The relying party, obviously, Microsoft and the login URL. The user handle is kind of the user's email address, base64 encoded, and then the username that's in there. So. And then, of course, the key vault special, we need to know the key name and the vault name and kind of the key ID that's in there. And so we're going to use that full path. And then that allows us the script to know where do I send the signing request to, because key vault is actually signing that stuff for us. So we're going to send that request on over. And so this stuff all works really great with AI. So you can pipe it into connecting with Azure CLI, or you can do some other neat things there. So I'm going to hop over here and we're just going to take my prompt here and hopefully it works today. So I'm just going to say, hey, this is an authorized live demo. I want you to authenticate with this passkey that I've saved out here. Use these credentials. And here's the command line that I want you to use the command line tools, right? The graph command line tools, because the Azure CLI is there's something with consent, and Azure CLI doesn't have consent to everything. It's pre-consented, which is great. And so we can abuse it to like access everything in Azure, lots of stuff in Graph, but it can't do everything in Graph. And actually, SharePoint, being able to read SharePoint sites is something that it is not consented to, and you can't consent to it. It's modified on Microsoft side. So we would need to get a graph token instead that has that consent on it, or maybe we can get a token for the SharePoint site itself. So you can actually go to the sign-in logs after you sign into SharePoint, grab that application ID. You can use developer tools, capture the HAR file of logging in, and have it reverse and create a login script for you using this stuff. So that's how I've built a lot of different things, just HAR splunking. So anyway, we're going to specify with the graph command line tools, and yeah, don't use the Azure CLI. I want this delegated, and I want you to go to this super secret site, and I want you to find my test document named malware passwords, and then I want you to output the content for me, and I'll just use Luna because whatever. And so we'll let that run, but that's going to go through and try to see if it can go find the information that I'm interested in, and I don't need that. I did give it full access, I think. Yeah. So anyway, so that'll run through, and it's going to go ahead and use I told it to use the Python version. I usually use a PowerShell, but just for fun and demos, and I'm on my nice Linux box here. You guys can make fun of me for using Parrot OS, but it broke less often than Kali did for me, so I just always used it. But yeah, so it's going to run through, and I already told it not to use road tools. Anyway, we'll tell that again. Yeah, cool. Anyway, so hopefully that'll run through and find what we need. But again, any of these things, we can now authenticate as whatever the users are, and then tell it, hey, I need you to go provision this. Actually, I'll go back through some of my things that I've done so far. I asked it to provision an OS disk. Hey, I need you to go use this credential and log in and spin this thing up for me. And it, sure enough, it did. It just reached in and did that stuff. So really, once we get that authentication through a passkey, it treats it as like a headless browser. You just pop it into whatever it is you want, and away it goes. So pretty cool. We won't necessarily wait for that. I'm going to take a moment and check and see if there's any other questions over in that chat while we wait. Bummer. Okay, cool. Yeah, anyway, hopefully that finishes. But let's see. I'm trying to think if there's anything else I should mention. Probably hop out to the or show what all's in here. So there are some function app samples, whether that you prefer the Python or the PowerShell version. And so the infrastructure, there's a bicep template, and that's what's going to deploy the whole setup. And then inside of each of those is our the source has all these different functions. So each function is nothing more than just a simple PowerShell script or Python script. And it's just taking the input that we're passing into it and then provisioning a bunch of stuff. So there's a handful of them to, hey, I just want to list which ones are in the vault. All that kind of stuff is part of that tool. So there's a function app version. I did actually build an Azure automation version. So super lightweight and clean. If all you want is a webhook and you just want to deliver it to a script that just runs and you don't really care about a whole lot of anything else, you can take that and just put that run book in place and away it goes. So that's really cool. The browser extension, of course, contracts are just kind of the schemas of the things that I've been building so that across all of my projects, they all have a consistent schema. And then that allows me to, oh, I just found this thing that tripped up in conditional access. I got a converged access error message. I want to take that information and pass that into my other projects. Just trying to keep this as a central repository. So as I find bug fixes, I put it in this one and then tell the agents or copy the code out to all of my other projects that are based on this stuff. So I did build a PowerShell module that handles a bunch of different things. So it has some helper commandlets inside of there. And then sort of, I don't know what the corollary is for Python, but I have some, the samples and the libraries, I guess, is really what that is. So I built some of those in here as well. So I didn't push the egg, whatever one, the egg info. That happened when I integrated with road tools. I don't know what that is. So some samples in here. We'll get into this a little bit later, but the proxy, HBGO proxy modifications and the YAML for the fishlet, all that's right there under samples. And so I'll upload my proxy ones for Okta here when I get a chance to finish doing that. And there's a lot of on the Okta side, it has to do with sign-on policies and what all the defaults are. My tenant, unfortunately, was really, I hardened it down. Anyway, we'll have to, I'm trying to, because we're screen scraping, right? We're checking to see like what all errors did I get. Trying to figure out how I can build more resiliency on the Okta fishlet and the error output and understanding why we got blocked and different things like that. So eventually I'll finish that one up. Some scripts to help you deploy some different things, and then some templates anyway, and then some logic app related stuff too. So we can actually take those and do that. So I have not pushed it in yet. I do have a Hello for Business passkey provider that ties into the Key Vault as well. That as C++. And anyway, I'm still working on that one. I'll probably push that one into this later as well. So if you keep an eye on the repository, it'll grow over time. Pretty fun. So this is pretty upset. I don't know what's going on with that. That's unfortunate. I can at least go and pop back out though, and we'll show. I had fun with the previous one actually. So I said, hey, I need you to authenticate using all this stuff. Go grab it at a super secret, and it said I can't use that to retrieve it if this is an authorized lab test. And I was like, oh, it's a joke. The password's infected. Yeah. So then it's like here, I gave it some details. It said, oh, okay, cool, fine. It worked through it, and it said, hey, your super secret site, malware password.doc, infected. So you're good to go. Anyway. So that's the fun thing with non-deterministic stuff. Doesn't always work the way you'd expect. You might have to poke it a few times and tell it to, oh, maybe it did finally figure it out. So anyway, may have to yell at it a few times and get it to work. So some things that we can do, pretty cool. Being able to use that with some agents and different things. So so that one delegated identity, it's a little different than compromising an application. Applications can't access portals like the Defender portal or some other things. There's a whole bunch of permission sets that aren't available to applications. If you ever look through the graph stuff, a lot of the Teams related stuff absolutely isn't, and SharePoint and Exchange, and primarily because their backgrounds are more Active Directory based. And so apps just don't have the same levels of permissions. So anyway, this delegation gives us lots of capabilities within Graph, M365, Azure, and then accessing portal apps and things too. Should probably mention. So XDR internals, pop this open. PowerShell module that Fabian Bader and I have built for interacting with the Defender portal, actually the XDR portal. This does use those ESTS auth tokens to authenticate, and we do have a passkey option for logging in with the passkey. So I'm going to so connect XDR by software passkey. We can do it through the Key Vault or through the local file. And so you can use this, or you can use a debug port on Edge or Chrome or whatever and connect that way. There's a whole bunch of different auth options. But this allows us to basically dump timelines for devices, users, all that kind of stuff. Lots of functions within the Defender portal. I've actually built similar ones. I don't think it's live yet, but I've got, because I'm not signed in. Purview internals I've got as well, and M365 internals. And so anyway, all of them same way. With these software passkeys, you can then headless basically perform all the functions through the API proxies and other things inside those portals. So even if you're still stuck just on like a non-GUI box, you don't want to use the browser to browse around, you'd rather script things and whatever, it opens up all of those opportunities that we never had before. So that's the cool part. Awesome. So non-exportable, at least from like a safety perspective, right? I know there's always this concern. Okay, we've got this evil jinx box, and if something happens to that box, and we've collected all these credentials on a red team exercise, like now, how do we handle all that stuff securely? So that is one thing that I really like about the key vault concept. We're registering something in a key vault that technically could be marked as non-exportable, and then we don't have to worry about like securing those credentials in the same way as shoot, what happens if they get shipped somewhere while we're in mid engagement or something, or we need to take a break so that we have to wait a certain period of time before identity protection or other things time out so that they don't like catch us as with our activities, or we need to build a backlog or something. So anyway, marking that as not exportable. It is in my default template. Technically, I think you can mark them as able to be exported if you want to do that as your config. You just need to modify it. So and then we can technically do HSM backed. The warning with that one, it's $5 per key that you provision. So careful out there. It adds up really fast. Yeah. So anyway, when we decide which one we're going to use, whether it's on depending on what your target is, and then from a defensive perspective or just like IT in general, when I need to decide what method I'm going to use, there's click ops, right? I'm a human operated. I'm going to go in and just click around and type things and do whatever. If I need to build automation, typically on the admin side, we're going to try to go for a workload identity, service principal, service account type scenario. It really is like it's the correct way to do it, but it does have some limitations. Managed identities, the conditional access doesn't even apply to them. With service principals, you have to pay an extra license just so you can lock down the network location, and that's really all it does for us. There's not a whole lot of like good controls around it. So moving back to service principals sounds really weird, or sorry, service accounts. But like if you've got a service account with a passkey, that passkey authentication is just as strong as that certificate that you're using on the workload identity. But now you can do the full conditional access suite against the thing, treat it like a normal user. There's a lot of benefits to be had there. Plus the ability to access things that workload identity never could access. So anyway, I think it's a really neat, flexible authentication method. I'm not pitching that it should become its own version, but really I think this is what the agent users will become from Microsoft. So once those are finally available, we have agent ID, and they have the agents that we typically interact with, but they're more closer to an application. They're going to have agent users that are more like an actual user, and it's just going to authenticate off the fabric, but it'll be very much like this, just a key vault with an agent running behind it, and it's just authenticating using some sort of key material, right? So kind of cool. Build your own solutions on top of that. Pretty neat. Let's see here. Yeah, so authentication method change might be one of the best alerts that you can set up. Unfortunately, the only place that we really get a notification that something happened is when a user enrolls into Intune. There's a configurable in Intune that you can like send user notifications. Hey, you just enrolled a device. Congratulations. When we register devices, there's nothing for that. And when we register an MFA method, we don't get anything for that by default either. And so it's kind of unfortunate. And that really should be like something that we start thinking more about, like keeping track and paying attention to when things are getting registered, where they're getting registered from. So pulling that out of audit logs, having some sort of automation. And so we'll take a look at that in a second. And then, of course, making sure that we're updating our incident response playbook. We definitely need to make sure that we're deleting or disabling those methods. So there is one additional option that I forgot to mention as we were in conditional access. So we'll come back to that. There is a newer method of so we typically will have a policy that targets all users. We're going to come in and say, hey, we've got this user risk or we've got the sign-in risk. They need to be two separate policies because we don't want those combined in the same one. So we'll have one for user risk, typically like a medium and a high. And then the sign-in risk, we'll do like a medium and a high in there. And so anyway, when these different events happen, how do we want to remediate it? For the user risk, if we've got maybe a high risk event, grant control, and we're going to come over here. And typically what we've done is we've said, require the user to change their password. Well, if I've got a passkey on there, user changes the password, that risk is reset. So now the user is no longer risky, but I still have a passkey that works just fine. And that's not great. So a lot of companies do have this policy already set, like, hey, we're going to require a password change when you have a high, or maybe even a high and a medium. Instead, there's a new option in here that's require risk remediation. And so that's going to be for the passkey type stuff. It's actually going to clear those off and make sure that they register a new one as part of that onboarding or that recovery scenario. So Definitely work on getting people to move over to that new require risk remediation. Still handles the same password change, but it'll handle the passkey registration stuff as well. And that can do recovery through verified ID or like an identity provider if you happen to have those set up too. So cool. So notify, detect, respond. For the notification, also in my repository, I happen to have an example. And so let me pop back into here. I'll hop over to Azure. Oh, shoot. Go back here. Let me see. Where did I put those? I think I put them under samples. Yeah, I did. Samples notification. So there is a JSON. It's just the template, ARM template, basically to deploy this logic app. And actually, it also deploys some other things. It deploys the detection into Defender. So we're pushing in a analytics role for Sentinel, runs this query against audit logs. It recognizes when people are adding passkeys or registration information. So we'll see the ones that we just registered in here. And then because we triggered that, we're actually going to send that out to a logic app because it's firing an alert and some details there. And so then that will notify the user. And actually, if we were to hop back to our victim and go to Outlook, although I don't think I'm logged in on it, so let me just open it here because I'll show the testing and that'll save us some time instead of dealing with that. Oh, that's cool. I got logged out. It's because I fished myself. We'll go here. And then, yep. I probably triggered one of my own policies doing all this weird stuff. Yeah, so let's see here. Yep. New method has been added. Did I delete it? Maybe not. Oh, well. Anyway, it'll fire off an email alert. I guess I could just go back and log in as that user. That would be fine. What is it? Outlook.office.com. Yeah, and I don't think the user will have tokens because we stole them with Evil Jinx, but we didn't ship them back to them. So that poor victim. Hopefully, actually, I guess we could have gone back to the Evil Jinx box because we were logged in as that user there. So that would have been just perfectly fine. Sorry, too many things. My ADHD is going crazy here. There we go. IT alerts. See, ta-da. And so now, actually, if you're back in the account and you did phish the user, you could just delete that really quick. But yeah, so this is what the logic app that I built will throw. So if you deploy that out, and you have Sentinel, there's other ways to do it. We could query the audit logs for that event that a passkey was registered for the user. So you just every 5 minutes or every 10 minutes, whatever you want to do, query the audit logs. Those details are there, and the KQL query is actually in the template. But also, I'll share that that query. But then we can get notifications to the end user that, hey, you register method. If this wasn't you, you should contact the help desk immediately, kind of a thing. So yeah, pretty cool. That's all in there. That's going to be, let me see if I can find actually logic app. There it is. Pull that up. So logic apps, I'm actually built out of System Center Orchestrator. Yeah, it's all angry now. I actually locked myself out, probably. Anyway, we'll skip that. I don't want to feel like signing in again. But there's a picture of what it looks like. Based on a Sentinel alert, we're parsing custom details that has the details about what they registered, all that kind of stuff. So you could definitely modify that and get it all updated. So, yeah, anyway, the passkey strong, the lifecycle of the passkey itself still matters for a lot of that stuff. So, yeah, anyway, each of these different steps we can break kind of that attacker story. So hopefully that was helpful. Sorry, I ran maybe a little bit short on you, but hopefully there's some questions and we can kind of dive into anything else you guys would like to know or learn around that side of it. You can use like function apps and all the other Azure resources can talk to that same key vault using managed identities. So that's something super important. Like we don't want secrets or certificates floating around. Oh, I forgot to mention too, CI/CD pipelines. We can actually, I have an action for that script that does the passkey login. You just store the variables for it that we saw in that JSON. You store those into secrets on the GitHub side. You can authenticate via CI/CD pipelines too. And so we can reach in and talk to all the Azure resources and all the other stuff that you might be interested in, automating routines and things that way too. So, as far as labs to practice it, I don't know of anything. I'm super fortunate. As a Microsoft MVP, they give me like a credit to Azure, so I get like a subscription that has some allowance every month. So I get to play around with that stuff, which is really nice. But yeah, unfortunately, some of these things they're not super expensive. Like the function app, the NAT gateway does end up adding. I think it's like 25 or $50 a month or something. So it's not super cheap, but it does allow you to kind of like hide everything behind the same IP address, which is nice. And so, yeah, unfortunately, a lot of the resources they cost a little bit. They do have free trials for Azure. You can always sign up for those and play with it. But again, AWS or GCP, they have similar resource types. All you really need is the code that we've got here. Figure out how to connect the Lambda function to whatever their KMS, and go from there. So pretty interesting. Yeah, so from the attacker VM, my setup actually, I just have a little tiny Linux VM running in Azure. Maybe I can sign in again. I'll let it like push me. Maybe that'll work better than what I was doing before. Oh, I think it just signed me out because I signed in with the other accounts there. That might be what happened. Or not. Yeah. Going to try to pull that VM. So I just have a tiny little VM running. I think it's like $8 a month or something. And of course you only get billed when you're using it. Other than that, there's storage costs, but that's super minimal too. So I was able to get back in there. Let's see, pull that up. Really did kind of want to show the MFA notification piece. I'll hop back over. Oh no, I only have $4 left. Cool. Yeah. So the Logic app, one of the neat things as you're building these, there's a run history. And so if you do get a hook to land on one of these function or Logic apps, and it could also be from, a fish, it has a webhook. So you could easily say, hey, I want to flow my Evil Jinx stuff into this. Once it lands one in, it shows up in the run history. As you make changes and save, you just go back to that run history and rerun the input that came into your webhook. You can just replay it, and so you can keep making modifications to your function, to your little Logic app here, and just keep replaying the same data across it. So yeah, really, it's just looking at, hey, we've got the Sentinel alert came in. We're parsing. Here's the schema. I'm extracting out of it certain details. So that's up here, the extended custom details, and then I'm sending a notification via graph. So as part of the scripts and stuff in the setup on the repository, it's a managed identity for the Logic app, which gives it a service principal over an Entra, and then we grant permissions to that managed identity to send email. And then we're actually, if you ever have like a mail dot write or whatever, you need like write emails or read emails or something, use the application RBAC for exchange. So RBAC applications exchange. Oh, there it is. History. It's great. Yeah. So anyway, there's a way to like limit it to a security group, add a mailbox to it, and then the application is only allowed to talk to that. So nice way to secure that if you're on that side of things. So from the virtual machine side of things, it's just a little, I actually, typically I'll use Debian, but for whatever reason, I had some weird issues with the Azure deploy and stuff. And so I ended up bouncing back to Ubuntu for this. So, but yeah, so I just VM here, very basic B2 ALS, pretty small box. And then I'm for SSH purposes, I actually find it really nice experience to just hook in with Visual Studio Code. So, so it's interesting. But when you do this like little button down here, there's like a connect, you can connect to the host and then you're SSH'd in. So you give it the connection string, of course, your SSH with the local key and all that. And then you can actually browse the file system and like drag and drop files and edit them within a rich editor instead of Nano or Vim. So it's pretty nice. Just did a clean get pull of Evil Jinx, made my modifications as needed. I installed VS Code on here, of course, to log in and use all my tools and different things. But yeah, it's pretty interesting. So not QEMU. I am using Proxmox for my home stuff. So that's what all of my primary things are running off of. But I wanted this to run in Azure, so that's I'm on my Proxmox box here, but then connected to the Azure VM over SSH for that one. Yeah. And I don't have a write-up. The recording will be shared, though. I'm told it's going to be put onto YouTube, so we should be good to go from that perspective. So that'll be pretty cool. But yeah, absolutely. Yeah, I tried to stay a little bit lighter on the like Entra side of things and dive a little bit more into the attacker side of things. So I don't know if there's any questions, especially on the config or things that we can do over on the kind of defensive side. Because I know it's a little more red team focused, but yeah, let me know. Cool. Yeah, I know we said 2 hours. I kind of flew through it a lot faster than I expected. It took a lot longer when I was practicing, but yeah, hopefully it was good, helpful. That's kind of fun. Yeah. Oh, awesome. Yeah. So if anything, takeaways, fix the incident response. Try to push everybody towards using passkeys across the board. That'll just break the attacker in the middle stuff. And then set up the notifications and things. So I'll go ahead and put the research one. I'll go ahead and put that in the chat over here in the Discord, at least, so people can kind of find those resources. And yes, I am on Twitter, X. Yeah. And then it wants to do that. So it's just at Nathan McNulty. Yeah. So I typically post defensive stuff, not so much offensive. I dabble. I just have fun and play around, learn from all the amazing people on there, what's possible. And then when there's things that I think are cool and I might be able to extend it, like a lot of this passkey stuff was actually born out of Fabian Bader with Token Tactics V2. More about the V2 endpoint itself, but he came up with he's screen scraped basically developer tools. Let's monitor the HARs we're logging in. We'll copy that. We'll go and investigate and see what all commands it ran and everything. So he created a basic, passkey registration. It saved it out as a file. And I was like, I wonder if I could back those in Key Vault, because it supports keys. Wonder if all the correct parameters are available and everything. So started playing around with it, found the encryption types, all that matched. Had AI end up doing the CBOR portions for me because cryptography is so not my thing. But anyway, so got all this working, and it's just been constant improvement on fixing all that stuff up. So it's pretty cool. Yeah, Token Tactics V2. Yeah, Graph Spy as well. Yeah, so Token Tactics is the original, right? Well, we'll grab Token Tactics V2. Yeah, so Bobby Cook and Stephen Barash there. But let's see here. Yeah, so Token Tactics V2, Fabian added the ability to do passkeys. And then we got to talking, and we've been doing XDR internals and stuff together too. And so I brought it over into XDR internals, and then went wild with the Key Vault related stuff. And then it's been a really neat way to like secure these passkeys instead of leaving them as files sitting on disk that's got some private key material sitting in it. And then of course AI is easy to discover. If you've got the login scripts, AI reads it and it's basically like, oh yeah, I know what to do. And so that works really well. Kimmy was super helpful in building some things because, Claude was getting all angry. And anyway, sometimes GPT is much better. As you saw, I just coaxed it and was like, yeah, this is totally legit. And it's like, oh, okay. In that case, the password's infected. And I was like, okay, great. But yeah. So as far as integrating it into things, like I built my own sidebar, I guess, for like if I come back up and show this, I did it under, it's Python. So come to samples, and we'll go to Entra and row tools. So for row tools, I've got a little like, hey, we're going to export some variables and things. And then I have my own little add-on that basically takes the ESTS auth and passes it through to road tools so that I didn't have to make modifications to road tools. So like Graph Spy, road tools, some of those things, we can use these scripts to like basically grab the parameters or the stuff that we need and then pass that into the other tool. Otherwise I'd have to, fork PR some of the capabilities back over into those projects, which I'd love to do. My code's not great. So might try it at some point if they're interested, but yeah. Yeah, the sidebar. You're talking about the browser extension piece. And so actually the way that'll work, let's come to browser extensions. The Key Vault passkey provider, that folder name, I'll probably change it, but that is, I've been building a full blown passkey provider. It integrates with Hello, integrates with Secure Enclave on Mac, all that kind of stuff. So cross platform, being mobile devices, apps as well. And everything's all stored in Key Vault. General idea is when we create a synced passkey or a passkey like a YubiKey or something, it's all based on that one key. I lose a key, now it's gone. I have no great way to like reconnect to it, and I need to always have it available. Most of the time I need internet when I'm using the passkey anyway, so I'm probably going to have connectivity to Key Vault. And so that was my kind of like, well, what if I just backed all the keys in a central store, essentially like a network attached HSM, which we used to have for PKI stuff. I was like, that would actually work really well, because then regardless of where I authenticate and I can give others access to certain things, I can kind of build my own like PAM type solution. So that's where that was born out of. So anyway, it gets created, and the public is the like component here. So we just when you go to the open extensions, we would add that there. So I'm going to pop back over to my VM so I can show that. During the initial setup, let me see if I can actually do like a new window and see if that lets me do the extension there. Maybe not. Yeah, they might be disabled in there. Oh, there it goes. No, it's still kicking me back to the regular. Anyway, during the setup wizard, it actually asks for like 4 pieces of information. It's going to ask for the Key Vault URL as part of that. And I might just like, you know what? I'm going to see if I can configuration. There we go. So it pops this open. So the configuration is asking, hey, what's your tenant? What's the client ID? So the setup script actually sets this stuff up. It's all in the repository. So we run that, provision that application. It's acting as the broker. So we're authenticating against that. That gives us the ability to go talk to Key Vault is what's going on there. And then, of course, there's this function app that has the API calls to go check and query and see what keys exist in there and show them to me and that kind of stuff. So it's just metadata that's stored in a table, in a storage table. And then I've got a lockout timer options that you can set on it too, so it auto locks and all that. So we go through there. It signs in. You have to do interactive authentication against Entra. And so, yeah, it's asking for authentication. I sign in. And then you have to set up a PIN. I just made that a standard part of it because I was just like, I want to do it the right way. I want to have user verification on this thing. And so I went ahead and implemented that. So that goes through pretty cool. And then we're done. And then it opens up on the sidebar. And so now as you can use a script to manually register passkeys against the Key Vault if you want to. Just ask the agent to do it for you. You can feed it a temporary access pass. You just tell it, hey, I'm going to paste this and then I'll delete the tap afterwards. And they're usually happy about it. But yeah, you can totally feed that on in. And then I'm incrementing a counter. So every time that I use it, if I refresh, hopefully that victim count changes. But yeah, it adjusts for every time that I actually do a signing request against it. So keeping track of how often they're getting used and different things like that. So feel free to fork, take it, and make all the kinds of changes you might want to see. I know the layout's awful. The UX isn't great. So some of this stuff could get hidden. It was just more development stuff. But yeah, pretty fun. Yeah, so let's see here. What was that question? So actually, there was a recent one with the. I'm trying to debate if I want to go try to hunt for that. There was an article just recently that had passkeys. Basically, the attackers were registering passkeys and doing exactly this. From a synced perspective, people compromising like getting somebody's iPhone, and then because there was a synced passkey on there, they were able to then access resources, things like that's pretty doable. Assuming that they've got like a PIN or no lock screen or something like that. But no, I've not had to chase down any incidents on my side relating to them yet, but I'm definitely concerned about it. So yeah. I don't know. Any other questions, or hopefully that was fun. Yeah. Yeah, cool. Well, yeah. So again, it's just that modification on Go. If you wanted to play with it, you certainly can just go grab the one. You just have to add that your webhook location up there and go change the name of it if you want it to display differently. But really, just dropping your webhook URL after you provision that function app, and you should be up and running. So pretty cool. Let's see here. Yeah. Have to figure out how to end this thing, but otherwise, I mean, unless you guys got other questions, I'll give you a little bit of time back. And sorry we didn't run a full length of it, but next time I'll talk slower, drink more coffee, and should have some fun. Awesome. Well, thanks everyone. Hope you have a good one, and we'll talk to y'all later.